Hey everyone, we're going to go ahead and start lesson 5 today. So I'm going to start off with a little warm up here, and you can take a moment to go ahead and answer the question. So when looking at this equation, 5m equals 25, what does it mean when a number and a variable are placed right next to each other in an equation? And that number that's attached to that variable is called the coefficient. So what does it mean with that 5 being right next to that m? So I want you to take a moment, go ahead and share your answer down at the bottom. You can go ahead and pause the video and take care of that. All right, so hopefully what I think you probably came up with is you may have came up with the answer, 5m equals 25, and part of you might have just been like, well, I know the answer to that one. It's going to be 5, because 5 times 5 is 25. And you'd be correct, but the question really is what does it mean whenever you have that variable right next to that number? And it just simply means multiplication. So 5m is 5 times what number equals 25? So hopefully that's what you got. So today what we're going to talk about is we're going to keep on looking at scale factors, and we're going to look at what the effects are of different numbers on scale factors. Okay? So by the time we get done with this, our goal is going to be is I, the student, can describe the effect on a scaled copy when I use a scale factor that is greater than 1, less than 1, and equal to 1. And also, I, the student, can explain how the scale factor that takes figure A to its copy is related to the scale factor that takes the copy back to figure A. In other words, if I have an original image, I go to, say, a copy of that figure B, what was my scale factor? And if I want to go from figure B back down to figure A, what would my scale factor be there? So as we go along through this, hopefully it will clarify what we're really meaning by those learning goals. All right, so first off, kind of off that warm-up that we did, we're going to go through some slides here. And I'm just going to go ahead and get all of them up here on the board. And what I want you to do is look at each of these equations and really look at them and see if you can just mentally kind of solve them. See if you can find x when it comes to these equations. So the first one is 16x equals 176. And if you think back to what that warm-up was, that 5m, what does that mean? It means multiplication there. So 16 times what equals 176? And you may know the answer, but more importantly, you want to see how did you get that answer? Like, how did you justify what that answer was? Okay? So take a moment, pause the video, and then pick up here in just a moment after you kind of work through each one of those and see if you can kind of solve those mentally real quick and see if you can notice a pattern. All right, hope you had some time to work that out. So let's take a look at these real quick. So 16x equals 176. What do we have here? Well, hopefully you thought that the answer to that was 11. So how did you get there? You may have done some division, small division, just 176 divided by 16. Or you may have thought about it in the way of, well, 16 times 10 is equal to 160. And then how far away is 176 from 160? And it's 16 away. So you need one more 16. So 10 plus 1 is 11. So either way, hopefully you figured out that the answer kind of was 11 on that. So let's look at that next one. That one's a little bit trickier. So 16 times what equals 8? And a lot of people tend to want to go, well, it's 2. 16 times 2. And you're not totally incorrect, but it's not 16 times 2, because 16 times 2 gives you what? It gives you 32. So people look at that and they say, well, I need to divide by 2, right? Well, 16 divided by 2 gives me 8. So how can we look at something when we're trying to divide, but we need to multiply? And we talked about that the last couple lessons. And this is where you look at multiplying by the reciprocal. So if 2 is the number that you're trying to divide by, dividing by 2 is the same thing as multiplying by 1/2. So if you look at that real quick, we can work it out up here on the screen. So 16 over 1 times 1/2. And whenever you're doing multiplying a fraction by a fraction, you multiply straight across. So 16 times 1 is equal to 16. And 1 times 2 is equal to 2. And so therefore you now have that 16 divided by 2 that you were looking for. And that does answer that question. So 16 times what equals 8? And that 16 times 1/2 equals 8. So I know that one was a little tricky. It did trick a lot of people up in the other classes too. So now let's look at this one here and see if we can use what we learned from that last one a little bit more and see if we can pick up something on this one. So 16 times what equals 1? So if it helps, 16 divided by what equals 1? So let's think about that. So 16 divided by what equals 1? Well, 16 divided by 16 equals 1. But how do I do that? If we kind of look at the one that we just did up here at the board up top, we notice that, well, 16 divided by 2 is the same thing as 16 times 1 over 2. So if we need 16 divided by 16, then we should think it'd be the same thing as 16 times 1 over 16. And we can do the math if we want to on that one. Like I said, sometimes it's easier to see it once you write it out. So 16, we can rewrite that as 16 over 1 because it's easier to make both of them fractions. So 16 over 1 times 1 over 16. And those are multiplying straight across. So 16 times 16 gives you 16. 1 times 16 gives you 16. I think I said that wrong. So 16 times 1 is 16. 1 times 16 is 16. And what is 16 divided by 16? That indeed is going to give us 1. Right? So it does give us that answer. So what does all this mean? Where are we going with this? So let's look at the next one, and hopefully this will kind of solidify what we're trying to prove here. Is when something is divided by itself, as in 2 divided by 2, you're going to end up with the answer of 1. 3 divided by 3 is 1. So if you look at 3 times 1/3, it's the same thing as dividing 3 by 3. 2 times 1/2 is the same thing as dividing 2 by 2. So this next question is 1/5 times what equals 1? Well, hopefully you're kind of seeing the pattern on this. So if you take 1/5 and you multiply it by what we call the reciprocal, it's just simply flipping it. If you multiply it by the reciprocal, which is 5 over 1, it will give you 1. And we can work that out here just to make sure. So 1 times 5, or 1 over 5 times 5 over 1, multiply straight across. 1 times 5 is 5. 5 times 1 is 5, which does indeed give us 1. So hopefully with that, you're able to see that pattern that we're talking about. And that is to where on this last one, 2/5 times what equals 1. So hopefully you see that you just take the reciprocal value of this one, 2/5 times 5 over 2. Okay? So if you need to go ahead and pause the screen, look through that a little bit, and see if all that makes sense to you. All right. So what does that leave us? What we're kind of finding out here is multiplying by a fraction that's less than 1 will result in a product that is less than 1 of the factor. That's kind of wordy on how that sounds, but simply what we're looking at is if you multiply by something that is less than 1, like a fraction, kind of like what we were looking at in this example with 1/2, in this example with 1/16, we're multiplying by something that's less than 1. So what it looks like is that's all it's saying is the product, meaning when you multiply something together, that's called the product. The answer is going to be less than what that original factor was. So 16 times something that's less than 1 is going to be less than 16. 16 times something less than 1 is going to be something less than 16. And 8 is less than 16, and 1 is less than 16 on both of those. So, and then two factors that multiply to be 1 are reciprocals. And that's more what it was talking about when you go down to those fractions that we were just dealing with, to where this one is 5/1, and if you multiply that out, it does equal 1. And that 1/5 and 5/1 are reciprocals of each other. And the next one is 2/5, the reciprocal being 5/2. So when you multiply reciprocals, your answer, that product, is going to be equal to 1. All right. Hopefully that wasn't too confusing. So let's go ahead and go on. So on this one, we're going to do a little activity. Excuse me. The link is here for you to go ahead and click on. And here's the instructions, is you're going to sort the cards based on their scale factor. Be prepared to explain your reasoning, and more so, look at cards 10 and 13. And what do you notice about those shapes and sizes of those figures? And what do you notice about the scale factors? And then go ahead and examine cards 8 and 12 more closely and do the same thing. What do you notice about those figures and those scale factors? And so go ahead and get into the activity. And if you want to, you can pause the lesson once you get in there and show you what it is, okay? So this is it here. And just to kind of show what you can do, you can select these and then you can drag them around. So that way you can move them wherever they need to go. And the point of this is to simply try to organize these. How would you organize them? And one person may organize them a little bit differently, but we're going to look at organize them by scale factor. Okay? So, how can we do that? So the first thing I look at is, are we scaling up or are we scaling down? That's one way to sort them. And then if you look at some of these, it might be to where they seem to be the same size. So I'll go ahead and do one real quick. So like on card 1, we're scaling up. So maybe I'll just put all the ones that look like it's scaling up over here on that side, and all the ones that look like it's scaling down over here on this side. So I'll let you look at those for a moment and see what you figure out. So go ahead and pause the video, play along with those, and see what you come up with. And once you get done with that, go ahead and type down here and explain your answer on, why did you sort them that way? And why did you put which one where you put it? Okay? All right. So the next thing on there, it says, examine cards 10 and 13 more closely. What do you notice about the shapes and sizes of the figures? What did you notice about the scale factors? So 10 and 13 are going to be these two right here in the middle. I'll zoom in a little bit so everybody can see them a little bit better. What do you notice about these two? Well, if you said that they look like they're the same, just kind of reverse. Card 10 is scaling up from A to B, and then card 13 is scaling down from A to B, you'd be correct, because it looks like it's doing the same thing. And what it's doing there is it's showing you that you can go both directions. So what is the scale factor on that? So yet again, let me see if we can zoom in just a little bit more. So what do we get here? So if we look at each one of these more closely, we'll be able to try to figure that scale factor out. So the first one, where's there's a good line at? Let's say I like smaller numbers because they're easier to do math with. So if you go across A, it looks like it's one block right there. And that same spot, that coordinating spot on B would be right here. So that's 1. And this one is how many blocks? Looks like 3. All right. So what's the scale factor on that one? And simply put, the scale factor is just what is the number that we multiply by to get the larger scaled copy. So what did we multiply 1 by to get to 3? And it's just simply we multiplied it by 3. So this one, the scaled factor, sorry about my handwriting, is 3. Let's look at the other one. So same thing. Looks like this one side is 3, and that one is 1. So what are we doing there? We're still not multiplying by 3. What are we doing? How do you get from 3 to 1? So think about that for a moment. And you may be tempted to say that you divided, and that would be close. But remember, when we're dividing by a number, the scale factor is always going to be multiplication. So how could we do that? I'm not sure what happened to my 3's there. So instead of dividing by 3, it would be the same thing as multiplying by 1/3, right? So on card 10, our scale factor is 3, but on card 13, our scale factor is 1/3. So one we're 3 times as large, and the other one we're 1/3 the size. Does that make sense? Hopefully it does. All right. So what's this next thing say? So examine cards 8 and 12 more closely. What do you notice about the figures and scale factors? So 8 and 12. So which ones are 8 and 12? So it looks like these here. What do we know about these scale factors? So let's just find a side. And it doesn't really matter which one we look at. Let's look at card 8 first. And let's just look at that right there. It looks like it goes across 2 of those squares. And that one also goes across 2 of the squares. So what's our scale factor there? What do you multiply 2 by to get to 2? 2 times what equals 2? Hopefully you said the answer was 1, and that is going to be the scale factor. I'll just abbreviate it right now as F. So let's look at this other one. Let's look at 12. So we can take it any point we want to as long as it's the same on both. So let's take it from here over. And we have what? 1, 2, 3, 4, 5 squares. On this one, we have 1, 2, 3, 4, 5 squares. So what do we multiply 5 by to get 5? 5 times what equals 5? And the same thing on that one is 1, right? So what are we noticing there? So if we have a scale factor that's 1, that means it's going to be the same size of the original, right? So hopefully that kind of makes sense a little bit. All right. So moving on. So how did you sort your group? And more likely you did it kind of like how we talked about, scaling up, scaling down, and then equal. And here, take a moment and kind of look at these and see if you can answer which ones are which. Which one has a scale factor that is exactly 1? meaning the scale factor is 1, so it's going to be what? Scale copy is going to be equal to the original. Looks like card 8 is going to have the scale factor of 1. Which one has more than 1? As in, which one is going up? So card 1 looks like it is more than 1. And then which one is less than 1? Because remember, if you multiply by a fraction, you're getting smaller. So this one is less than 1. And this kind of thing about it is, if I was block A up here, I would say, man, block B is bigger than me, right? How much bigger is it? So we can look at the scale factor. That adds up to be 2. And this adds up to be 4. So what do we multiply 2 by to get 4? And that's 2. So if I was block A, I'd be like, man, block B is twice my size, right? But if I was block B and going back the other way, I'd be like, man, block A is half my size. So that's kind of what's happening down here on card 3, right? So it's less than 1. All right. So here, card 2, if a scale factor from A to B is 3, what is the scale factor from B to A? And hopefully you're kind of catching on to this already. So let's look at that. So if we go from A to B, scale factor is 3. But if we're going back the other way, so this way is 3. What happens when you go this way? Remember what we said before, kind of like A is looking at B going, man, he is 3 times my size. B looks back at A and goes, man, that one is 1/3 my size. It's just that reciprocal, right? So let's look at card 7 and see if we can figure it out the other way. So card 7, A looks at B and goes, wow, you are really 1/2 my size, man. Didn't know if you knew that these blocks had personalities. So what did B say about A? It's like, well, if A is B's 1/2 A size, that means A is 2 times B size, right? So it's just that reciprocal. You're just flipping that number over. All right. So let's skip this slide. And kind of come to this one here. So this one doesn't have the sizes on it, but we should be able to tell some things about it. So what do we know about the segment lengths and angles if the scale factor is 3? First thing, what do we know about the angles, right? What do we know about the angles? When we're talking about a scaled copy, the angles don't really change, do they? So if this is a 90-degree angle here, this also will be a 90-degree angle. So we know that now. We talked about that before. But what do we know if the scale factor is 3? What do we know about the lengths? So sometimes it's easier if you just, even if you make up some numbers, let's say if the length of this one is worth 2, what's the length of this side here if our scale factor is 3? And that scale factor simply means that's what we're multiplying it by. So 2 times 3 is equal to what? So equal to 6. So what if the overall height of this 4, what if that was equal to 4? What would be the overall height of this 4? What would that height be? Remember, the scale factor is 3, so it's 4 times what the scale factor is, which is 3 because it's given to us. 4 times 3 is 12. Hopefully you got that one right. So, and that's kind of all that we've been kind of doing. Okay. So, what happens to the copy when it's created with the scale factor? Think about these for a second. So what happens when the scale factor is greater than 1? What happens when it's less than 1? And then what happens when it's exactly 1? And some more to think about. How can we reverse the scaling to get back to the original figure when we have a scaled copy? So how can you go back? So if you went from A to B, how do you go from B to A? Okay. Well, if you got some time to think about that. So some takeaways that we should have on here is when the scale factor is greater than 1, the scale copy is larger than the original. If the scale factor is less than 1, the scaled copy is smaller than the original. And if the scale factor is exactly 1, then the scale copy is the same size. And then scaling can be reversed from like that A to B and then B to A to reverse it by using that reciprocal factors. So in other words, if A to B, if B is twice the size of A, you can flip that and use that reciprocal, and B is half the size of A. So you just flip those over, all right? So the last thing you should do is kind of look at these goals and see if these make a little bit more sense to you now. Can you describe the effect of a scaled copy when you use a scale factor that's greater than 1, less than 1, and equal to 1? And can you explain how the scale factor that takes figure A to its copy, figure B, is related to the scale factor that takes figure B to figure A? So hopefully you can do both of those. And if you did, congratulations. You knocked it out of the park. So just kind of solidify those thoughts a little bit. There's a little cool down here. This is going to be the cool down that you guys have already in your assignment. So do the one that is on the Summit platform if you're a virtual student. If you're not a virtual student, you can use this link here, but it should be the cool down to make sure that you understand that concept. All right. Well, if you have any questions, let me know.